Everything changed yesterday. What they have discovered is nothing short of revolutionary. Imagine a leap in computing that shatters the limitations of every machine we've ever known. What these scientists have done is take a fundamental breakthrough, one that seemed impossible just a year ago, and turned it into a tangible, powerful reality. They have found a way to make a topological conductor out of a molecule that until recently, barely existed in the realm of scientific knowledge. For decades, researchers struggled to solve one of the most elusive problems in modern computing, topological sorting. It sounds abstract, but it's actually the backbone of much of what we depend on every day. From artificial intelligence to logistics, from cryptography to global supply chains, topological sorting is the unsung hero that keeps complex systems functioning. But for years, it has held researchers back. The process of organizing interdependent systems, the kind that are everywhere in our digital and physical worlds, was a monumental challenge. Now, a radical breakthrough in quantum mechanics has made solving topological sorting not just possible, but exponentially faster than anyone imagined. A leap that could change everything. Michio Kaku, one of the leading voices in modern physics, has long been a vocal advocate for the inevitable rise of quantum computing. He predicted that quantum computers would eventually surpass the power of classical machines in ways that might seem almost magical. And that moment might be upon us. With this latest discovery, we've crossed a threshold that could rewrite the very definition of computation itself. At the forefront of this revolution, scientists at MIT and Google's Quantum Air Lab have developed a quantum algorithm that isn't just incrementally better than its classical counterparts. It's exponentially faster, a leap so massive that it defies comprehension. What once took hours or even days to process on traditional computers now happens in a mere fraction of the time. The implications of this are nothing short of staggering. This breakthrough isn't just a faster way of doing things, it's an entirely new way of thinking about computation. Imagine AI evolving at an unprecedented rate. Imagine encryption systems rendered obsolete overnight. The future of information, security, and computation itself might need to be completely reimagined. But the implications are deeper still. Some researchers are beginning to worry that this level of computational power might be too much, too soon. Quantum computers don't just process information the way classical machines do, they explore multiple possibilities at once, simultaneously navigating through entire networks of data in ways that are still beyond our full understanding. Could this new form of computation eventually lead to intelligence beyond our control? Could it open doors to a deeper understanding of reality itself? To fully grasp the magnitude of this discovery, we first need to understand why topological sorting has been such a daunting challenge for traditional computers. It may sound like an abstract concept, but topological sorting is the critical process that keeps complex systems running smoothly. Think of it as organizing a complex construction project. Some tasks, like laying the foundation, must come before others, like installing the windows. It's about figuring out the order of steps in a sequence. And this challenge is everywhere in modern computing. In artificial intelligence, machine learning, data science, and logistics, we rely on sorting massive datasets to train algorithms, predict trends, optimize systems, and solve problems efficiently. It's also the key to cryptography, where the security of data transmission depends on the complex ordering of encryption layers. But topological sorting has been an absolute nightmare for classical computers. The problem is this: as the size and complexity of datasets grow, the time it takes to compute the correct order grows exponentially. Traditional machines, no matter how powerful, can only process sorting step by step. For smaller tasks, this is fine. But when it comes to sorting massive interconnected data structures, classical computers quickly hit a bottleneck. systems slow down, and progress stalls. Now, here's where quantum computing completely changes the game. Instead of evaluating one possibility at a time, quantum computers use the principles of superposition and an entanglement to explore multiple pathways at once. This allows quantum algorithms to vastly accelerate sorting processes, overcoming a critical barrier that traditional computers could never surpass. It's not just a small improvement, it's a quantum leap in computational speed. Imagine a library filled with millions of books, scattered and unordered. A classical computer would painstakingly go through each one, finding its place in the sequence one by one. But a quantum computer doesn't need to do that. It simultaneously looks at every book's position at once, instantly determining the most efficient way to organize the entire collection. This parallel processing of possibilities is the secret sauce behind the speed and power of quantum computing. The implications of this are nothing short of transformative. AI systems, which depend on sorting and analyzing massive amounts of data, could now evolve at speeds we've only dreamed of. Cybersecurity, a field heavily reliant on topological sorting, could be completely revolutionized, potentially making current encryption systems obsolete. What was once thought to be a near impossible task, like simulating the complexity of molecules or predicting the effects of climate change, could suddenly become feasible, with unprecedented accuracy and efficiency. And while this is already mind-blowing, some researchers believe we may be just scratching the surface. If quantum computing can solve topological sorting at such speeds, what other fundamental problems in computing could it solve next? What challenges that once seemed insurmountable could quantum computers unravel in a blink of an eye? This isn't just about faster computation. This is a fundamental shift in how we approach information, technology, and even reality itself. We are on the cusp of a new era, and some believe this is the first step toward an intelligence explosion. But perhaps the most shocking part of this discovery is the realization that the future Kaku predicted, where quantum computers would begin to solve the unsolvable, has now arrived faster than anyone anticipated. This is no longer science fiction. This is happening right now. For years, skeptics argued that quantum computers were too far off, too theoretical, requiring conditions so extreme, like near absolute zero temperatures, that they would never be practical. But as this latest breakthrough shows, quantum computing isn't just a far-off dream, it's becoming a very real, very powerful force in the here and now. Michio Kaku was one of the first to recognize that we were approaching the limits of classical computing, and that quantum mechanics would be the key to overcoming them. He often likened the arrival of quantum computers to the shift from vacuum tubes to transistors, a moment so profound that it would redefine everything we thought possible with computers. Now, with this breakthrough in topological sorting, Kaku's predictions are no longer just speculative, they're beginning to look inevitable. But if quantum computers can already tackle problems that once seemed insurmountable, what's next? What could the future hold when quantum computing begins to solve not just sorting, but every challenge that classical computers cannot? What new frontiers could be unlocked in artificial intelligence, cryptography, and even scientific discovery? As AI becomes exponentially more powerful, there's a very real fear that it may soon surpass human intelligence. The gap between human cognition and artificial intelligence could shrink in ways we never imagined. What would that mean for the future of work, society, and humanity itself? At the same time, quantum computing could also render the encryption systems that protect our most sensitive data completely obsolete. Financial transactions, classified government communications, even private emails, nothing would be safe from quantum hackers unless quantum-resistant cryptography is developed to stay one step ahead. The race to protect the world's information has already begun. Then, there's the impact on science. Imagine simulations so advanced they can model entire molecular structures, simulate chemical reactions, or map quantum-level particle behaviors in seconds, not years. Medical discoveries, drug research, and breakthroughs in physics could accelerate at a pace humanity has never seen. And while this all sounds incredibly exciting, it raises a very unsettling question: are we ready for this level of advancement? The quantum revolution is no longer a theoretical discussion, it's happening right before our eyes. And while the potential benefits are endless, the risks, too, are enormous. We are entering a world where air-powered quantum machines could change not just the way we compute, but the very fabric of reality itself. This is just the beginning. What comes next is not just about faster computers or better algorithms, it's about rethinking what is possible in a quantum-powered world. What do you think? Will quantum computing reshape the world as